All right, let's implement remove on our doubly linked list. We're almost there. So we need to specify the index that we're removing at. And we first check if that index is invalid. I'm actually just going to copy this from insert. So if index is less than 0, or if it's greater than, except this time, or equal to the length. Because unlike insert, where we could insert right at the very, very end, if there's 8 items, we can insert at index 8. If we're removing, the length is 8 items, there's nothing at index 8. So we need to check if it's greater than or equal to. Return false or undefined. Otherwise, our next thing is to check if it's at the very beginning. So if we're trying to remove from the very, very beginning, let's just do a return this dot shift, which should remove the thing at the very beginning. If we're trying to remove at the end, which we could check if the index is equal to the length minus 1, we're going to return this dot pop. And let's just make sure that that works. Run our code. Let's do this list dot remove 0. And that gives me the first node. If we look at the list, it's only 2 things. So I could do a remove at index of 1, which now is the last index, and we get Hermione. And we look at the list, it's only 1 thing. So if I try and do a list.remove of 1, it's invalid. If I do 0, it works, and our list is empty now. Looks good. Now the rest of our logic, we're going to use the get method to retrieve the item to be removed. So let's do that now. We'll make a variable called removed node equals this.get and just pass in the index. So that gives us the thing that we're removing. Now we just need to remove it by setting the next and previous properties to the correct things. So I'm going to set the node before it. So here, let's go do A, B, C, D, E, F again. If we're trying to remove this node, this is removed node, we need to set this node's .next to be this node's .next. So we leapfrog over it, which now sets B's .next to be D. So that's removed node dot previous gives us B dot next. The dot next of B should be equal to removed node dot next. Now I don't really like doing this dot previous dot next, so we could also do what we did earlier and make a before node and an after node. But I'm going to start with this. So that's one connection from B to D. Now we need to go from D to B. So removed node dot next dot previous equals removed node dot previous. So removed node dot next D dot previous is now going to point to removed node dot previous, which is B. I know it's kind of crazy. Otherwise, all that we have left is to set next and previous to null on the found node. So that's just cleaning up some loose ends. So removed node dot next equals null. Removed node dot previous equals null. Then we subtract 1 from the length. And then we just return removed node. Let's see if it works. I'm going to test it out. So we have our list. Let's do list.remove index of 1, which is Ron. So our list should now have Harry connected to Hermione. So the head is Harry, and its next is Hermione. And if we look at Hermione, its previous is Harry, and there is no next because it's the tail. If we try to do list.remove an invalid index, -1, we get undefined, or 100 or 10, undefined. Let's do a couple pushes. Okay, I pushed in a couple values, LOL, bye, and ha ha ha. So if we look at our list now, it's 5 items. If I try and remove from the very end, if I do list.remove 5, it doesn't work. But if I do list.remove 4, it works. And notice that what we get back has no next and no null. That's correct. We don't want it to have the lingering references. So we get list dot, let's look at the tail now, which is by, and next is correct. It should be null. It's the end. And previous is pointing to some other node, which is what I'm saying by. Okay, this all looks good. Let's just remove from the beginning. Let's just remove a couple times. How many things are left? Okay, we should be done now, right? It's totally empty. Everything looked good. You could clean this up a bit, and it's up to you if you think this is cleaner, but you could do var before node equals removed node dot previous. Whoops. Var after node equals removed node dot next, and then we could do the same thing that we had before. So we just set before node dot next equals after node, and then say after node dot previous equals before node, if you don't like this syntax here. And if we refresh it, I run the code again, it should still work just fine. We have our list, nope, list with a T. If we do list.remove at index of 1, and we look at the list, it should be correctly patched still. So we have Harry, which is pointing next to Hermione, and Hermione is pointing previous to Harry. So up to you which you prefer. This is a little more verbose, but then you have this nice, clean, easy to understand syntax here, what you're actually doing, versus before it's a little longer, and you have this removed node. Everything is in reference to removed node. Honestly, I don't know which one I prefer. For insert, when we had to change more properties, I like doing this. For removed, either one. I think I'll leave both in here and just leave it commented out. Okay, so that's remove.